Linear function. Please read the definition. We have here f of x is equal to ax plus b. And this is in a form also y is equal to ax plus b, where your y, it's your f of x. This is just the function notation. Again, f of x is just the function notation. And then the domain, which is our x, in the range, which is our y values, it's just negative infinity to infinity, so all real numbers. And also we have the standard equation for a linear function. So the standard equation is ex plus by is equal to c. Okay. In here also we will learn about slope. So that's our m. That's our slope. And that is the rise over run. So m here in this equation, it's your a. So that would be your m. And remember, there are three kind of linear function. So we have this type, and this one is the increasing function. And the other one, it's the decreasing function. The last one, it's the horizontal line, which is the constant. So talking about slope here, slope on the increasing function would be positive. And talking about the decreasing function, our slope here, it's negative because it's going downward. In constant, the slope here, it's m is equal to 0. Okay. So let's have an example. So in here, you're asked to graph, and then you're asked to find the domain and range. So the only way you can actually see clearly the domain and range is through graphing. So we learned from the last presentation on the formula y is equal to mx plus b. So where your m here, it's our negative 2, and our b here, it's the positive 3, which is the y-intercept. Okay, so we can actually do something like this. This is our y, And here's our x. And then negative 2, it's our slope, and positive 3 is y-intercept. So we pick first our y-intercept, which is 3. That's our first point. 1, 2, 3. So let's mark that one. And then we need another point so we can make a line. So it's a negative 2. So our slope here, it's negative 2. So m is equal to negative 2 over 1. Negative 2 is our rise, and 1 is our run. So it means from point 3, we go down 2 units. 1, 2, and then we move to the right 1 unit. So we will get um, this point here. So we'll mark that. Okay, again, 2 units down and 1 unit run. Then you can actually connect the 2 points. So that would be our graph. And if you're going to be asked what's the domain, domain here is your x values. So if you're going to look at the line, it's moving downward and it's moving upward, and it occupies all values for x. So you will get all real numbers or negative infinity, infinity. So this is also true for the range. So if you're going to look at the range, it's your y values. So it occupies, because the line is moving upward and it's moving downward. So it occupies all the y values for your line. So it gives you all real numbers also. Okay, so that would be our first example. Now, what if you're asked to find all the intercepts? So let's say you're asked to find all the intercepts. So the first one, we have already the y-intercept. So we can write that out as y-intercept in ordered pair form. That would be 0, 3. So that would be your point. For the x-intercept, that would be the point of intersection between your x-axis and your line. So we can actually solve that by doing this. F of x is your y equals negative 2x plus 3. So we're solving for x-intercept, so we let y is equal to 0. So that would be 0 here for your y equal to negative 2x plus 3. And then solving for our x, we move the x term to the left side, becomes a positive 2x is equal to 3. Divide by 2 on both sides, therefore x is equal to 3 over 2. So your x-intercept would be 3 over 2, comma 0. Okay, so that's how you solve for your intercepts. So one is given, that's the y-intercept, and the x-intercept can be solved. Okay, next example. You have x is equal to -3, and still you're asked to graph, and then you have to find the domain and range. Okay, so let's graph it. So this is our y, and this is our x-axis here. And that is x is equal to -3. So we're looking at -1 here, -2, -3 is here. And then that should be a vertical line passing through -3. So this would be your x is equal to -3 line. Okay, and that's the answer for the graph. For the domain, you have only one point for the domain. So your answer would be just -3, because that's the point that the line is crossing. And then we have the range. The range, you can see it's pointing upward and it's pointing downward, so it occupies all y values. So that would be all real numbers, -infinity, infinity. Okay. If you're going to be asked the intercepts, you have only one, so that would be the x-intercept. So the x-intercept here is just -3, 0, y-intercept none. Okay. Let's have another example. How about f of x it's equal to 2. So you're still going to be asked to graph this and find the domain and range. Okay, so we have to graph this one. And we have a y axis and we have the x one. And remember, if you're going to think about f of x, that would be your y. So this can be written as y is equal to 2. So what it means that you have only a point here, which is 2, and the line is just crossing at the point, which is a horizontal line. So the point is over there, which is 2. So that is a horizontal line. This is our f of x is equal to 2. Okay, so it's a function. So because if you draw a vertical line, then you have only one intersection. That's the vertical line test. So this one is a function. So that's why we use the function notation. Okay, so that's a function. Now remember a while ago, we have the vertical line. So that's not a function. because you have a vertical line and you have more than one intersection. So if you can see, there are points along these lines. So you have plenty of intersection for the vertical line if you apply the vertical line test. So a vertical line is not a function, but this one is a horizontal line, so that's a function. And for the domain, so you're asked to find the domain here. Domain will be all real numbers because it occupies all the x values. For the range, you're only intersecting one point, which is 2. So that would be just the solution set and then 2, because you have only one point for the range. If you ask about the intercepts, okay, so we have only graph, domain, and range. But if you ask about the intercepts, you can answer that when looking at the graph and also looking at the equation. So it's only crossing the y-axis. There's no x-axis. So only y-intercept is here. So y-intercept would be at 0, comma 2. For the x-intercept, since we don't have one, you can just write none. Again, there's no x-intercepts because that's a horizontal line. Okay, so let's summarize all the formulas. This is for, so let's have that slope, and this is the m, and this is the rise over run. So this is how the line is inclined, or the inclination of the line. So that's rise over run. Or in application problems, this is the average rate of change. Rate of change. Okay, first formula, it's finding the slope. M is equal to um, y2 minus y1 all over x2 minus x1. We call this as 2-point slope form. Okay, so why is it we call that 2-point slope form? Because you're given with 2 points. So this is the second order pair, this is the first order pair. So 2 points, and then we have a slope. The second formula, it's y is equal to mx plus b. So we know already, we used this already. The m here is our slope, and the b here, it's the y-intercept. So the name for this formula, it's slope intercept form. So that's the name of the formula. And then the third one. The third one, you have y minus y1 is equal to m times x minus x1. So that's the third formula. And we call this as point slope form. Why is it point slope form? You're given with a slope and a single point. So here's the first point. So again, 1 point and a slope. So we call this formula as a point slope form. Okay. And then there will be information that we need to know here. When the two lines are parallel, the two slopes are equal. M1 is equal to M2. So that would be two parallel lines. M1 is equal to M2. When you have perpendicular lines, okay, it means that your slope, your first slope is negative reciprocal of the second. So that's actually the formula. You can also say here, let's just put or, M1 times M2 is equal to -1. So that's actually the same. So M1 is equal to -1 over M2, or M1 times M2. If you cross multiply, it gives you M1 times M2 is equal to -1. So they are just the same form. Okay, so what do you mean by parallel lines? When the two lines are not intersecting. So I have a line here, and then I have another line, and if they are equidistant to each other and they don't touch to each other, then that would be parallel lines. For perpendicular lines, again, for perpendicular lines, it's like the x and the y axis. It's like forming a cross or a plus sign. And the angle would be, they're making a 90 degrees angle. So that would be the perpendicular lines. Okay? And plus Mr. Slope guy. So in order for us to remember the line that is going up, it's positive slope. The line going down would be a negative slope. And the line that is vertical, you have undefined, the U there. And the line that's horizontal, that would be M is equal to 0. So that would be the Mr. Slope guy. Okay? And you can see, you can remember that for a long time if you see the face of Mr. Slope guy. Again, increasing, going up, positive, going down, negative for slope. When you have a vertical line, the slope is undefined. When you have a line that is horizontal, then you have a slope of 0, or M is equal to 0. Okay, so that's Mr. Slope guy. You can balance the 0 here on the other side, and that is still a face for Mr. Slope guy. Just for you to remember. So memorize the three formulas. Those are the only three formulas that we need to know for the slope and information about parallel lines m1 is equal to m2, perpendicular lines m1 is equal to negative 1 over m2, and memorize the phase of Mr. Slope guy. So you will know if the function is increasing, decreasing, constant, and undefined also, if that is a vertical line.